What is up, everybody? Welcome back to Case Digital. My name is Zach. In today's video, we are showing you how you can visualize sorting algorithms in Python. So right here, this is an example of us visualizing selection sort, and this is basically the tool that we're going to write to help us show us sorting a list of an array of integers, and how we can leverage the selection sort and visualize that selection. So without further ado, let's hop right in and start coding. All right, so to go ahead and create that application that we're gonna do, I have this just created this list that we're gonna use for this whole process. And then we essentially need a sorting algorithm. So in my previous video, which I'll link right here, I did a video on how to do selection sort. So I'm gonna go ahead and copy this function that I created to do that. And we're gonna go ahead and paste that right in here. And now for that animation portion that you saw, we have to go ahead and install a few things, or just basically one library, which is matplotlib. So matplotlib doesn't come in, is not built in within Python. It needs installed from using pip. So to do so, we're just going to say pip install and then matplotlib. But before you do that, I highly recommend, I have a virtual environment activated over here, so I don't have any weird issues with installs and it doesn't mess up my system, Python. So I highly recommend that you set up and activate and use a virtual environment. If you don't know how to do that, I have a video right here you can go check out. But essentially, if you go ahead and hit pip install, once you have that activated and running, you can go ahead and run it. And again, mine should already have it installed, so it shouldn't install. And yeah, it looks like it's good. So now what we can do is we need to, from matplotlib, we need to import two things. We need to import a package called animation, and we need to import a package called pyplot, because that is basically what we're going to use to kind of get that graphic and to do the animation, right? So we're going to say import matplotlib.animation. And the nice thing too is with Python, you can, if you're not familiar with this, you can do as and then do animation. And what that's going to do is rather than having to type this whole thing in, matplotlib.animation whatever function we're going to use, it just kind of you can do this thing to say, hey, give it this nickname that when anytime using this whole setup, that's what we're going to use. And then we can say import from matplotlib.pyplot. This is the very common plotting package. And we're going to say as PLT. And this is very common. A lot of people use pyplot as PLT. So once we have that installed, we should basically be good to kind of get going, right? That's all the imports that we need. This is kind of the function that we're going to use. Now we just need to go ahead and write all the code to do and leverage the selection sort and do the animation with it. So let's hop right in and start doing that right now. All right, so to go ahead and to animate the sorting of our list, what we need to do is we need to leverage the from animation dot, there is a function called func animation, and you'll see essentially that this is a timed animation subclass that makes an animation by repeatedly calling a function, and it has certain parameters that we're going to pass it. So we're going to do this in stages because we're going to kind of start with we're going to set everything up to see as it would run. And then we're going to go ahead and create the different functions and the things that we need to kind of do this animation. So for this, you'll see that this func animation takes in a figure, which is often a that whole graphic that you need. So we're just going to put a placeholder of a variable called fig, and we're going to put it right in there. And then it's going to take in a function. So this is the function that you are going to repeatedly call to update and do kind of our animation. So we're going to call this update plot. All right. So that'll be a placeholder there. We'll create that function here in a minute. But then after that, we have to do what's called the frames. Now, what I've learned from this is in doing this, there's two different routes that you can go. You can go the route of passing in the data that's going to be used for each frame, which will get inputted into the update, and in our case, the update plot function. Or you can give it a number, and then that will create that number of frames, and then you can use that to do some sort of iteration with. And so the route that I went when I was testing this and kind of learning this before I kind of making this video is so frames is going to be equal to, and I'm going to say that this is going to be the length of our current list. So what this means is I'm using the part where we're going to just pass it a number, and it's going to create that number of frames for us. And the number I'm passing is, we only need the number of frames to do our animation, which is basically the list of this is the length of this list. So that's how we do that. And then from here, there's you can see there's an init function that you can do. When I was testing this and learning this, I didn't really use an init function, but there is this fargs args function that is used. And basically, this is going to be the stuff that you are going to pass in. So, for example, like this could be, well, for sure we're going to want to pass in our data that we're going to get from our current list when we do our sorting. So we could probably put that in there. So for now, we probably need to do something that says sort array is equal to selection sort and do cur list dot copy. And the reason I'm going to do a copy here is because when you do, everything in Python is passed by reference. So when you pass in a list and then you go through and iterate it, what's going to happen is it's going to, like, basically when it pops out, you're going to have, that's all going to be modified. And so I essentially just want to say, hey, I'm going to pass in a copy of this so that way we can use this guy, the current list in its state without being updated and modified where we don't want it to be. So that's kind of what that copy is doing. So we can pass in, say, this information, and just to make sure, I should be passing it as a list, but we'll just make sure it's a list. All right. So then after that, I did some digging because I wanted to see how I can control the time, because it says it is timed, and within there is a thing where we say interval, and we can say, I'm just going to say, so it does it in milliseconds. So if you put in 2,000, that is going to be 2 seconds. So 2 seconds per frame is essentially what I gather that it's doing. And then you can also say, hey, we want it to do repeat is equal to false, or you can put it to true. So if you want it to do like I did at the very beginning of this, I believe I had it on as true, and it'll just keep going back and forth once it's finished. Otherwise, if you just want to do the animation one time, you just put it as false. So, and then after all this is said and done, we need to go ahead and say plt.show. And I'll get to what this means here in a minute, because PLT is basically the plotting software. So when you create this fig, it's basically going to show that figure and everything like that. And if you don't do show, you'll end up nothing, you won't see anything, right? So the whole point of this is to be able to visualize it. So that's what we're going to do. So now we have kind of the basis of our main function that we are going to run. Now we need to go ahead and we need to create the stuff that's going to create our figure, as well as the function that's going to do our plot. So let's hop right in and start let's create a function that will essentially create our figure and set up our initialization of our figure. So let's start with that, and then we'll move to the update plot. All right, so now that we have the kind of skeleton of our program in place, I'm going to go ahead and backfill this with the creation of the initialization of our plot. So we're going to say init plot, it will be equal to, and then we'll pass in the selection sort array, or nope, pass in the current list. We'll pass in the current list. So the reason I'm going to pass in the current list rather than a copy is because what I want this to do is, and I probably want to move this, to be honest, down here. What I want this to do is I want us to use the list as is, and because that's what we're going to, like, it's going to basically start with the current list and plot the current list, and then we'll do the update plot to apply to that, so that we do it. So now we're going to pass in the current list for this one. So we're going to come up here and we're going to say def init plot, and then we're going to say it's an array, and then we're going to go ahead and we're going to set up our plot and our figure. So what we're going to do is say fig, and then axis is equal to plt.subclasses, or subplots, sorry, subclasses. And that'll give us our figure, and then this has the ability to, like, the axis to kind of set everything up on. So now what we're going to do is we're going to set the title to the whole plot, and then we're going to set the x-axis, or the x label, the y label, and then the limits for the x and y. And then we're going to and then basically we're going to create a bar graph, and I'll tell you why here in a minute. But let's kind of go ahead and go down in order. So if I say axis dot, and then we're going to set the x label, or set the title first. Set title, and then this is, rather than just saying selection sort like I did I think in the intro, we're going to say visualized sorting. That'll be the title, sure. And then for the axis, we're going to set the let's set the x-axis. So set x label. That's what we want. We want to set the x label, and then that's just going to be the index. Yeah, that's going to be the index of our list. So that should be that. And then we're going to copy this, so we can just change one thing. Y label is going to be the value. So this will basically be in our list right here. We have the values. And basically, the Y label will just represent the value of that index. If that makes sense. Yeah, the value at that index. So it'll be that. Now we need to set the limits. So I'll say x or axis dot set the x lim. Now what this is going to do is basically say where we want our x axis to be, and so it's going to ask you what the left side you want is and what the right side that you want is. And essentially I'm going to do 0. You could play with other numbers and say, hey, I want to do this graph that looks like this, and then whatever fits within that do. But we're just going to say 0, and then we're going to say the length of our array, right? So what that'll do is basically just plot everything between 0, like from the 0 index to the length of the array index. Now for the y though, we don't necessarily want that. And the reason being is because if I set it from 0 to the length of the array, well, if the length of the array is 10, look, we have values in here that are 20, 44, 21, 10. So I kind of think we want to do the max. Like we want the very bottom of y to be 0. Again, if we wanted to do another thing like negative something to negative or to positive something, we could. But I'm going to say 0. And I'm going to say the max part of the array. So in this case, I believe the max is 44. And then I'm just going to say to give it cushion, so it's not like the top of the plot is right up there. I'm going to say plus 10, and then plus 10. And that should give us kind of a nice cushion to the top of our, when setting up our plot, right? Just kind of give us that room that we want. All right, so from here, we need to go ahead and say, we're going to create a bar graph now. So I'm going to say bars is equal to ax.bar. Now what this will do, this is going to make a bar plot. And the bars are positioned at x with a given alignment. Their dimensions are given by the height and the width, vertical bottom. So the parameter is the x coordinates of the bars. So we basically just want our x coordinates of the bar to be our indexes, right? So to do that, so if our x value we're going to say is a range from 0 to length of array. And technically, we don't even need to do 0. We actually could just do length of array. And this will create a list for our x values of 0 to the length of the index, basically from 0 to 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0 to 10. And then that's our x values that we're putting in. Now our y values, well, we already know what our y values are. It's the data that we're passing in. It's our array, right? So I can say array. And then after that, you can give it colors. And I think in the demo that I did at the very beginning of this, I think the color was like sky blue equals sky blue. All right, with all that said and done now, from this initial, so since we created the figure, the axis, and then the bars, we probably want to return all of that out so we can use that down here below. So we're going to say return the figure, the axis, and the bars. All right, so then I can take that same information and I can say put it here. And now we have created our init plot, which has updated our figure part to be working. And now the only thing too is, well, our f-args, if we need to update our bar plot, if we need to update the plot, not only do we need to pass in the sorted array information, but we also need to pass in the bars, right? So I'm actually going to put these at the front, so bars. And then we get our list of selection sort.array. All right, so now the last thing that we need to do is basically update this plot that kind of shows what we're going to do as we're iterating through each frame of the plot, right? So let's go ahead and create that update plot function now. All right, so I'm going to scroll up here and I'm going to say def update plot. Now, so what I learned from this is this function that you put in here, what's going to happen is if you put in frames, if you put in the data, that's kind of the first thing that's going to be put in. So is going to be our frame information. However, we didn't put in the data for frame. We put in this int value. So that's basically going to pass in a frame, and that frame is basically going to be a number that we're going to use. But then we also say, hey, f-args, here's the other args that you're going to use. So you're going to have bars and you're going to have array data, or you're going to have an array, right, of your array of information. But here's the thing that I learned, that, and I'm going to write that in here really quick. So when you're using this, essentially you need something that like when I run this selection sort, what's going to happen is it's going to return back the complete sorted list, like just like what we have up here. So let's get down. It's going to return back an array, and that array is going to be sorted, right? Now, we don't necessarily want that for this, because what we're trying to do is we're trying to do this animation, and in this animation, it kind of needs something that is iterable, or it basically kind of needs an iterable of the data that you want to do. So basically, if we were to run this, we'd want to do like every pass that went through, every iteration that we went through this sorting, we need to somehow store. Now we could create a giant list and store that there and pass that data in. However, there is a different way to do this and a lot simpler way to do this, and that is by creating a generator function. Now, a generator function just allows you to get data by using kind of that iteration method. So like using the next or using like going through a for loop or stuff like that. And the nice thing is like turning this into a generator function is really easy. All I do is comment out this return or this line, and within the for loop, so after the end of the for loop, we're going to say yield, and this is the keyword for creating a generator. Generator functions, you do this yield function, and then we pass in the data that we want to use. So in our case, we want to say, well, at the current state of this pass, we want to return r.copy. So we're just going to return a copy of that array. Again, because everything's passed by reference, and so if we don't do a copy, things could get jacked up, messed up. Now, the other thing that I want to do, though, is you saw through that iteration, I was showing you that in red was the current step, or I guess it was this. In red is the current index that we were at, and then in green was the minimum value that we found. So what's nice is I can say, well, when we're going through this iteration, okay, at that it passed through, I found the data, that current state of the array. I is going to be the current index that we're at. And then we found the min index within that pass, and we put that as that label. So I could just say return min index. Now, what's nice here is I'm going to comment this out and put this stuff back. I'm going to show you the difference just from a print. So if I come in here and I'm going to comment all of this code out right here, comment that out, and we'll comment that out. So if I go ahead and rerun this with all of us stuff commented out, and I just have my sorting algorithm, go ahead, run this. You should see that we'll have a printout of the unordered and then the ordered list. So there's the unordered. Oh, my bad. So Python, how to visualize .py. That would help if I actually put the .py in there. All right. So, I didn't print it out. That's why nothing's printing. Ordered list, and then do that. All right. So go ahead, run this, and you'll see that we have their unordered list, and then we have our ordered list. So that's what happens when you just do the return. Like we end up with that list, right? Well, here's what happens, though, if we say we're going to turn this into a generator, is we comment that out, comment this back, put this back. And what you'll see is when I run this, it's going to show you the unordered information or the unordered list, and then you kind of get this generator object selection sort at this memory location. What that's going to allow us to do, though, is we're going to basically turn that into a list and put that all right here. So that'll give us that every time we do an iteration through, that we get the next information out when we do this update function. So that basically that subtle shift allows us to say, okay, first pass, we're going to update, and we're going to get that update in our graph and our animation. And then the second pass, or when it moves to the next thing, we're going to get a new update, and we're going to go update that function. And so that's kind of why we did that. So we've now switched it over to generator. We can put all this stuff back, put this back, comment that back out. Now what that is going to do is saying, okay, like I said, like that first pass, we get that current state, we get the current data. And then, yes, we get our current data. So array, we're going to say array data. And then we're going to say, because that's this stuff right here. The array data, the current index, and then the min index. All from the array, because it's a generator. This part we pass in as a generator of frame. And that frame comes from this part, again, this part right here. So these values right here is where we're getting this information from. And that's kind of what took me the longest part to figure this out, is that frame information come in. You could pass it in as the frame of data, the frames of data, or you can give it an index and say, here, like I want this int value, which is say 7 or 10 in our case, and that's going to create like, okay, now when it does the update plot, it's going to say frame is now 1 or 0, I guess, so 0 to 10. So 0, so array at that, so the generator at that is going to pass the first pass with this yield returns. So when we get that information, what we can then do is say for I, and then we're going to do bar and val in enumerate, and this is going to be, we're going to zip together the bars information and our array data. So this is going to how we can go take that array data information with our current bars and update everything so we get the color, the swapping of the bars, and all that stuff. So then we're going to come down here and we're going to say if I is equal to current index. So if our I value in this is equal to the current index in our animation, what we want to do is we set that as red, right? So we're going to say bar dot set, I think it's color, red. And then else if I is equal to the min index, then we're going to say bar dot set color, and that's going to, we set it as green. And then else, we're going to say that bar dot set color is going to be equal to that sky blue that we had, sky blue. And then we also, so that's just setting the colors of the bars. Now we need to go through and set the value of the bar, right? With that array data. So now we're going to say bar.set the height of it. So that's what it is, height. And that's just going to be the value from our array data, basically. So as this is, and this will be the array data. So the current state of whatever array that we pass in, this will be the value that we're setting that height of that bar to. And then we can just say return, or yeah, after everything is said and done, we can say return, again, not spell, bars. So then this will just return the updated bar information, which will then go into the graph and kind of, or go into our plot. So with all that said and done, we actually might be able to go ahead and run this now. And yeah, that's all good. So if we go ahead and run this, we'll see what happens. So it's going to go through, initialize the plot for us. It's going to create that generator, go through the generator and get everything information, all that information. And then, oh, it looks like we have a warning or an error down here. So we'll close this out right here. PLT.show. Move this down a little bit, see if that was causing an issue because, all right, let's try. So bars, selection sort, B. All right, let's try to run that again. Python, okay. Yeah, so we have our list. We've done the selection sort generation. And one sec. See what's not updating correctly. Oh, I see why it's not showing up. Oh yeah, so you have to assign this to a variable. So that it gets kind of attached to that figure. So you kind of, yeah. So if I rerun this again, there we go. Yeah. So you do have to assign that to a variable so it can help get attached. I believe it's so it can help get attached to the plot. But if I'm wrong in that, please someone leave a comment below and let me know why, what I may have been missing there. But now you can see that it's going through. The green is the smallest index at the current time. It swaps them and then we get that. So that is how we visualize the sorting of our selection sort. Is all we had to go ahead and do is we created these two functions that help deal with our data. And now we could do this a little bit different too. I just wanted this because I wanted to show the min information that came out of this. Now you could create, now maybe this plotting isn't, maybe this is very specific to selection sort. And so you could say update plot underscore selection sort, because if we, ideally my vision for this is I want to use this code again, and I want to do several more videos where we create other different sorting algorithms, and then we update this script to essentially say, here's how you update it with the merge sort, the selection sort, the insertion sort, all these different sorting algorithms, and then we can show, hey, like over here is selection sort, and over here is merge sort, and we can give it the same list and have it sort it all, and you can see how each one of them is working. And that's kind of my idea for this. And so maybe what I did with this update plot is very specific, and that's probably because I said, hey, the very things that are kind of innate to the selection sort is like the array at the time, the current index, and the min index. Because what ends up happening is the current index and the min index, they end up swapping. So whatever you find, like if I found that the current index at one, say that my current index is 0, and I found that in our case, it's, so right here, the current index is 0 is 33. Well, the smallest value is 1. So 0, 1, 2, 3, 4, 5. What ends up happening is index 5 and index 1, they end up swapping. And I kind of just wanted this information to show that, so that we could update our plot and you can visually see it. So we may end up having to create additional functions. So maybe this is update plot selection sort, and then we come back down here and we update this. So when we run this again, and again, I can turn this repeat to true, and you'll see it as it pops up. Like it's just going to go through. It'll go through and do its sorting about 2 seconds per frame, and then it'll say, you know, swapping them, doing its thing for selection sort, and then after this, it should, after it hits this last one, it basically should go back through and it should say, oh, let's redo it again. And it'll just keep doing that until you're done. And you can also speed this up. This is 2 seconds per frame. You can say, I want to do half a second per frame and stuff like that. But this is essentially how I figured out how you can visualize sorting. If there's other ways or there's interesting news that other people have found, please leave them in the comments below. I'd love to hear about them. Again, we're all on this journey together, and this is just the things that I've been learning about and I've been interested in, and I just thought it would be helpful for other people, so that way you can kind of get a grasp of see like exactly how this sorting algorithm is working, rather than like having to write it out on paper, because that's the only way I used to do it. Like when I was taught this in school, we'd write it out on paper, we'd go through the algorithm, each line, and you'd see the updated basically array after each iteration through, and you'd see like, oh yeah, that's how it's working. It's taking these, swapping them, doing this, doing its selection and going forward. And you do that for each of the different things, and you'd see for each of the different algorithms how it work. But it'd just be nice. Hey, look, I'm swapping these things, and maybe this isn't intuitive too, but like, but for me, this was helpful. So I hope this provided value. If it did, please leave a comment below, or like the video as well. If you have any questions, again, put them in the comments, and we'll talk about this. We'll go through this and see what we can do to improve this, make this better. But until next time, keep on programming.